What if I told you that everything you learned about Jupiter in school was wrong? For decades, we've called it a gas giant. But the truth is far more bizarre and fascinating. Jupiter isn't a gas planet. It's a liquid one, hiding secrets that are rewriting our understanding of the cosmos. So, what did NASA actually find on Jupiter? Let's dive in. For a long time, we imagined Jupiter as a giant ball of gas, maybe with a small, solid core. This picture began to crumble in 1994, when the comet Shoemaker-Levy 9 slammed into the planet. The impact sent up plumes of material that shouldn't have been there, giving us our first hint that Jupiter's insides were more complex than we thought. Then came the Galileo spacecraft, which bravely plunged into Jupiter's atmosphere. It sent back data for 58 minutes before being crushed and vaporized, revealing that the pressure and temperature were far more extreme than anyone predicted. But the real game changer was NASA's Juno mission. Arriving in 2016, Juno has been orbiting Jupiter from pole to pole, peering deep beneath its swirling clouds with specialized instruments. And what it's found is truly First, let's talk about those famous clouds. They're stunning, but they're also incredibly thin, only about 50 kilometers deep. That's like the skin of an apple. Within this thin layer, chaos reigns. We're talking storms larger than Earth, winds screaming at hundreds of kilometers per hour, and something scientists call mushballs, massive hailstones made of ammonia and water ice. Juno also detected enormous lightning strikes. But unlike on Earth, they originate from clouds containing ammonia water solutions. This is an atmosphere unlike anything we've ever seen. But what lies beneath this chaotic skin? This is where the gas giant myth completely falls apart. Below the clouds, there isn't more gas. Instead, we find an ocean of liquid hydrogen, 20,000 kilometers deep. To put that in perspective, the deepest part of Earth's oceans is only 11 kilometers deep. The pressure here is millions of times greater than on Earth, and it's so intense that it heats the hydrogen to over 1000 degrees Celsius. So, it's a scorching, high-pressure ocean of liquid hydrogen. Go even deeper and things get even stranger. As the pressure continues to build, the liquid hydrogen transforms into something that doesn't exist naturally on Earth: liquid metallic hydrogen. The intense pressure squeezes the hydrogen atoms so tightly that their electrons are stripped away, allowing them to flow freely. This creates a liquid metal that conducts electricity. The vast, swirling ocean of metallic hydrogen is what generates Jupiter's incredibly powerful magnetic field, the strongest of any planet in our solar system, nearly 20,000 times stronger than Earth's. So, what's at the very center? For years, scientists assumed there was a small, dense, rocky core. Juno's data suggests otherwise. Jupiter doesn't have a solid, well-defined core. Instead, it has what scientists are calling a fuzzy core or a dilute core. It's a vast, soupy mix of liquid hydrogen, rock, and metal, spread out over a region that might be half the planet's diameter. It seems the original rocky and icy materials that formed the planet's core were eroded and mixed into the metallic hydrogen over billions of years. These discoveries have completely upended our theories about how giant planets form. No existing model can fully explain this fuzzy core, the liquid layers, or the bizarre weather. Was Jupiter formed by a massive collision that shattered its original core? Did it migrate from a different part of the solar system? The truth is, we don't know. Jupiter, the king of the planets, has shown us that it's far more mysterious and magnificent than we ever imagined. It's not a simple gas giant. It's a dynamical liquid world with a turbulent heart of metal. The more we learn, the more we realize how much is still left to discover. Thanks for watching. If you were as amazed by the secrets of Jupiter as I am, hit that like button and subscribe for more deep dives into the mysteries of our universe. See you next time.